What's up everyone? In this video, we're going to deploy VXLAN using Nexus 9000V. So I have here some documentation in regards to how it works. You can read more about the details in depth by reading these documents. And these are the ones that I would recommend to start off, as they're very simple and easy to understand. So essentially what we want with VXLAN, so we want our end hosts on the network to be able to communicate using an overlay network. So that's what VXLAN is providing. It's an overlay network. And this is provided by using an architecture that is often referred or called as spine and leaf, where we have the spines on the top of the network. Those might be your high-speed devices, can be switches or routers, and those spines, they connect to every leaf on the network, and the leaves, they don't talk directly, they only talk with the spines. And the leaves, they also, we have another terminology that is often used. It is VTAP. VTAPs are just the leaves that will encapsulate and decapsulate the tunnels. And another terminology often used is VXLAN VNI or VNID. So that's the VXLAN ID, just like we have VLAN number. Okay, so just to make this very easy and simple to understand, the way this works is that we have spines, like on the top of the hierarchy. We have leaves, like access switches, where you connect servers and hosts. Okay, and those leaves, they are also referred to as VTAPs. So VTAPs are the ones that encapsulate and decapsulate the traffic. That's where the hosts are sending and where the hosts are receiving the traffic. And we have VLAN, that's VLAN that we already use, and VXLAN ID. That's similar to VLAN ID, but that's for VXLAN. Quite simple to understand with this terminology. So in order to deploy it, we have to first build an underlay network. Essentially, this means, okay, we have to ensure that those devices, they are able to reach each other. Okay, and we can use any IGP for that matter, OSPF, ERGP, BGP, if you will. And we'll need multicast because of broadcast, unicast, and multicast traffic. And you're going to see how it is important. And to add some efficiency, if you can say that, we can use BGP or EVPN as the control plane. So in this video, we'll first just look at how to deploy it using what is called as flood alert behavior. And on the following ones, we'll see some more advanced scenarios where we use EVPN and other stuff. So let's bring the devices, and I'll start with spine 1, spine 2, leaf 1, and leaf 2. Now, leaf 2 it stopped the boot process at this part. So if your Nexus hangs on this process, all you have to do is to point to the NextOS image, and you can find out the NextOS image by typing dir, and you see here is the image, and you type the command boot nextOS 9.9.3.6.bin and press enter, and it's going to boot that image. Now let's begin with spine, and for me it's very hard to speak and type at the same time. So right now I don't have any layer 3 configuration whatsoever. So the first thing we want to ensure is reachability between the devices. So we're going to use OSPF, and we're going to use multicast, P multicast sparse mode to be more precise. So let's first enable the feature OSPF. Would be helpful if I could use both at the same time. So I was going to start with feature OSPF and PIM because it hangs. I want to take advantage. Okay, so feature OSPF and PIM. Another thing, okay, this is done. So let's enable the process. And I'm going to set the router ID to be 192.0.1, sorry, 2. I bet this is the router ID, log a JCC, and we're going to use the loopback interface as the RP, and on leaves, this is what we're going to use to encapsulate and decapsulate the tunnel. So that's going to be the VTAP. On the spines, we don't need that because they don't need to decapsulate and encapsulate VXLAN packets. They're just sitting on its data plane. So loopback IP is going to be 192.168.0.1.32. I'm going to advertise using OSPF area 0, and I want to enable sparse mode. So this is that. Now the interfaces that connect to leaves, they have to be layer 3 interfaces. So I'm going to select from 2 to 4, 1, 2, 4. And first, let's make this layer 3 interface. And VXLAN, it adds some overhead on the packet. So let's see if I can show what is it. What is it? 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 I believe it's here somewhere. It should be here. So the packet is an 8 byte. Anywho, whatsoever. The thing is, we have to account with this additional overhead of VXLAN. So we're going to configure jumbo frames to support this additional overhead. So that's a lot. So let's just do it. And what is line 1? Yeah. So we're going to say MTU 9216. And we're going to enable the interface. And what you're going to do as well is medium point to point to point, so that we can reference the loopback interface directly. And we want to enable OSPF and PIM with the leaves. Okay, this is done. So we're going to do the same on spine 2. So router OSPF, router ID 192.168.0.2, log, loopback, IP OSP first address 192.168.0.2, 32, IP router OSPF 1 area 0, IP PIM sparse mode. This is done. Now the interfaces is from 2 to 4. You know what? Let me just grab these from spine 1 because it's going to be the same thing. I hope I don't make a mess. Copy 2, 3, 4. Yeah, paste. Boom. It's done. Now let me grab leaf 1 and do the same thing. Admin password. So first thing first, let's enable OSPF, and then let's enable multicast. Done. Now let's enable routing process. So it's going to be router ID 192.168.0.11. And let's see. OSPF adjacencies. My loopback interface is going to be 192.168.11.32, and the routing process area 0, and I want to enable sparse modes as my interfaces from 1 to 2. And oops, let me get this. No, I can't. So let me just, no shut, no switch port, MTU 9216, IP router SPF1 area 0, IP PIM sparse mode, and IP unnumbered loopback 0. Oh yes, I forgot point to point, so that's why I had to do that first. And I should see OSPF adjacency, so it is enabled, it is, and show IP route OSPF, and we can surely reach 01 and 02, so I don't need to use do 192.0.1 sourcing from my loopback. That should work. Okay, you don't want, so that's just to use the IP, and should be 11. And it's going to hang for a while, and it's working. So some ARP process there, 02, and it's working. Okay, so we're going to do the same for lift 2. So starting EOIP. Okay, let's give some minutes. Meanwhile, so I have OSPF, I have show IP PIM neighbor, I have PIM neighbor enabled. So we are ready to start looking at the flawed and learned behavior. So first thing first, we have to make one of the spines or both of spines as the RP for the tree. So is it ready? Not yet. And we're going to choose spine 1 has the RP, and we're going to use static assignment. Yes. We're going to make IP PIM RP address going to be 192.168.0.1 for everything 224.0/4, and it has to be bidirectional. Now it might show this error, but trust me, it's going to work. I don't know if it's some platform related error, but anyway, let's go. So spine 1 will be the RP of the tree, and IP SSM range. So IP PIM SSM range is going to be 32.0.8. Okay, and this has to be, I don't need to use do, this is going to be the same on all the devices. I'm just going to copy these and paste. Going to copy and paste. And lift 2 looks like it's ready, so we're going to skip that. Yes, I want to skip. Okay, so let me check. So IP PIM RP. Yes, lift spine 1 is the RP. That's okay. So now let's enable the VXLAN features. And so it's going to be feature VN segment VLAN based, and feature I believe that's NV overlay. Yes, and that should do it. So let's you want secure password? Yes, I want. Let me type the password. And would you like, no, I don't want. To prevent the Nexus device to hang on the same problem again, so let me show you how to solve that. So first, host name, let's say lift2, and I want to do this boot NextOS in on boot flash, and it has to select the image. So the next time that this switch will be rebooted, that problem won't happen again. So it's going to stay there for a while. And now, so let's configure the access side from leaf 1 to R6. So we're going to use VLAN 10, right? That's what it says there, VLAN 10. And two features that we have to enable. One is interface VLAN. And I believe you're going to find out in a minute. So for VLAN 10 on port 3, so you're going to say this is an access port, and it's going to be on VLAN 10. So I'm going to place this switch on this VLAN as well, just for testing. So it's going to be 10, 11, and that's going to be 24. I'm going to enable interface VLAN. And let's see, 192.168.10.11, it's okay. And can I reach 6? I can, that's great. So if I look, oops, that's our 6 MAC address. So leave 2 still thinking, okay, no problem, take your time. Meanwhile, we have VLAN created. Now we have to associate the VLAN with VXLAN ID or VNID. So on VLAN 10, we type the command vn segment, and it's going to be 123.10, and that's it. Another error, and we need to enable or create the VTAP interface, and that's going to be NV1. You have to enable the interface, and that interface is going to be member of VNI 123 and we have to say to which multicast group this VNI will be associated with. So we're going to say this is going to be 224 and 65.74.5. That's it. It's done. So if we look, show IntVia 1, NVE is down. Admin state is up. What am I missing? No shot. What am I missing? Okay, so it's missing the interface where this traffic is going to be initialized. So source interface is going to be loopback and show int v1. So now it's up. That's what we want. Okay, that's great. And now let's look at leaf 2. Leaf 2, we're going to start everything. So right, OSPF. And actually, before enabling OSPF, I want to write, so I want to save this. Is it? No, it's copyright. Yes. It's going to take a while. Okay, so now I can enable OSPF and theme. We need PIM, we need what else? I'm just going to enable all the features that we need. We need PIM, we need interface VLAN, we need enable feature VN segment, and we need feature NV overlay. Okay. Great. Now let's enable OSPF, the RAR ID 192.168.0.12. Want to see the adjacencies, and my loopback interface is going to be 192.1.0.12.32. IP RAR OSPF area 0, IP PIM sparse mode, and that should do it. And now what I need is to enable the interfaces, and that's going to be 1, 2. So just copy from leaf 1, 1 and 1 and 2. Okay, so I'm just going to copy all of these to save time. A bit lazy, and it's done. Awesome. And while it's doing its thing, I'm going to create the VLAN and VN segment to be 1, 2, 3, 10, and one interface, switch port host, and switch port access VLAN 10. And for VLAN 10, IP address 192.168.0.12.24, no shot. And now let's see. What is the problem? Oh, okay, yeah, it's missing PIM. Copy this. Okay, now can I reach 10.8? No? What's the problem? 3. Probably it's down. Bring the interface up. And let me see, did I configure the IPA on R8? I did. So what is spanning to VLAN 10? It is, it's forwarding. Show MAC address VLAN 10. I know the MAC address, so what's the problem? That's interesting. I'm learning the MAC address, but layer 3 doesn't want to work. Oh, my bad. 92.168.10.12. Yes, now it should work on 92.168.10.12. So that's why first I like to ping myself. And 10.8. Yeah, that's great. If I look now at MAC address table, yes, so this is R8 MAC address. Okay. Now let's enable the VTAP interface on leaf 2. So let me see what is NV1. NV1, so I'm going to source this from my loopback interface. No shots, and just going to copy the same. Done. Confirm that it's up, up, up. That's great. That's awesome. Now we have to configure this group as well on the loopback interfaces. So, let me see where is the spine. I'm going to say IP IJMP join group, and that's going to be in 224. I believe it was 65.74.5. Yes. And spine 1. IP IJMP join on going to be 224 and 65.74.5. And the same for leaves. IP IJMP join group 224 and 65.74.5. And the same here. IP IJMP join group 224 65.74.5. So this is done. We'll look at routing table. So the outgoing interface, that's going to be 1.1. Okay, that's where the RP is located. So now let's see what we have so far. We look at the MAC address table for VLAN 10. So we see that right now we only know our directly connected host, and that should be okay. And the same should be true for leaf 1. Okay, so now let's try to send some traffic from R6 or from R8. I really wanted to show this using Wireshark. That would be more interesting. So let's see what we can capture. 10.6. So we know about, okay, so leaf 1 already knows about R8 MAC address. So we have this R process, okay, using the broadcast, and then is going to be delivered to the multicast group where both VTAPs are part of, and this is being delivered to R6. So this should work now, and it works. Okay, so we had that discovering phase, and now both VTAPs, they know about each host. So we can see on leaf 1 R8 is known, and if we look again on leaf 2, it knows about R6 MAC address via the tunnel VTAP interface. Okay. In the next video, we're going to use Wireshark, so can we have a more detailed look at this discovering process and how it differentiates from flood and load behavior when we're using BGP EVPN. I hope you guys enjoyed this one, and I'll see you in the next one.